Hello everyone, today my topic is solubility of gas in water. So for the part 1, I want to introduce basic information and background of gas solubility. Firstly, gas solubility in water is negatively associated with temperature, which means solubility will become less soluble with increasing temperature. So from this diagram, you can see that there are 5 major gases in our lives, and all of them shows a decreasing pattern. Next, gas solubility is positively associated with pressure. So I give a diagram group. In diagram A, the system shows a dynamic equilibrium, which means the gas dissolving rate and the leaving rate is the same. But when you push down the plate, which means decrease the volume and increase the pressure of gas, more molecules are pushed into the water, which means dissolving into water. So at this time, the dissolving rate is quicker than the leaving rate for the system to reach another dynamic equilibrium. After a while, you can see that in C, the rate will become same again, but there are more molecules dissolving into the water compared to the diagram A because of the increasing pressure of gas. So by summarizing the elements of related to gas solubility, I will introduce the Henry's formula. I write so many words here to introduce Henry's formula, and you can see that. Oh, okay, here is a diagram. You can see there are different gases with corresponding Henry's law constant, and interestingly, you will find that with increasing matter of each gas, the Henry law constant is increasing. So for part 2, I want to talk about the gas solubility related to marine environment first. So the ocean has an original pH is weakly alkaline, but there are continually carbon dioxide dissolving into the water, and the carbonic acid is produced, which will decrease the ocean environment, ocean pH environment. And this acid is not stable. It's not stable in the ocean water and will dissociate into hydrogen ions and carbonate ions. And for some marine life like coral reefs, they will use the calcium ions in their body and react with the carbonate ions to make CaCO3 to make skeletons and shells for protection. And some calcium ions floating in the sea will react with carbonate ions too to make CaCO3 sediments in the bottom of the water, in the bottom of the ocean. But here comes problems. With the increasing carbonic acid and hydrogen ions, the pH of the ocean is continually going down, and the hydrogen ions will be prone to react with carbonate ions to make HCO3, which means there are less carbonate ion supply for marine lives. So they will have less material to protect themselves. Also, as the pH goes down, the acidic environment will erode the skeletons and shells of marine lives, which may influence their normal lives. And this picture summarizes what I said before. So the biological and physical pumps of carbon dioxide shows that the carbon dioxide in the atmosphere dissolves into the ocean water, and by the two process as this picture, carbonate ions formed, and some carbonate ions were used by the marine lives to make shells and skeletons, and another part of carbonate ions are used as the bottom the bottom sediment. And after the marine life's death, it will experience organic process, deep water circulation and upwelling, and the carbon dioxide will reproduce and back to the atmosphere. Similar like that, the CaCO3 sediment in the bottom of the sea is not stable, and in the acidic environment, it will be eroded and experience deep water circulation, upwelling, and reproduce CO2 and back to the atmosphere. The topic 2 I want to talk about is thermal pollution. What about the thermal pollution? The lake or river water will be heated by the industrial reactor or power plant, so the water temperature is increasing higher than normal. So here comes problems. Because of increasing pressure, less oxygen will be dissolved into the water, and it may harm aquatic animals' lives. Also, because of the increasing temperature, the hot oxygen depleted water level will go down, and the cold with enough oxygen water level will go down, and the cold and oxygen deplete the cold and oxygen enough water will go down, and the hot with oxygen depleted water will go up. So it forms a barrier, which is a bad cycle that hinder the oxygen from dissolving into the water. Also, because the increasing temperature, many cold-blooded animals in the water cannot adapt in a short time. It will cause their death. The third topic I want to talk about is coke production. The major process of coke production are right here. Is a forward reaction, but carbon dioxide is difficult dissolving into the water, so the manufacturers decrease the temperature of CO2 and increase the pressure of CO2 so that the forward reaction can normally happens. But when you open the cap of the bottle or can, the pressure of the CO2 will decrease in a very fast speed, which means the backward reaction will happen in a fierce and quick speed and fierce state. So large amounts of carbon dioxide will bring so much water escape from the mouth of the bottle, and the mouth of bottle is so narrow and small. That's why when you open the bottle, the Coke bottle is just like a rocket or fountain. So for part 3, I prepare a easy question which related to Henry's formula. Okay, I will give my answer. The question is very easy. We just need to know what we know in the Henry's formula and we don't know in the formula. It's easy to solve. And here is the answer. Okay, at last, I want to tell you guys an interesting thing. You can see I put icy cold is great here. Why? Because the icy Coke is much colder than a normal temperature Coke. So the temperature of the carbon dioxide will be less. The carbon dioxide of icy Coke will be much more than normal temperature Coke when other conditions are same. So when you open icy Coke and a normal temperature Coke at the same time, in the same condition, you will find that this thing, the fountain or a rocket, will behave more fierce and more quickly than a normal temperature Coke. So the icy Coke is great. And at last, they are all references for the information I found on the internet. Okay, that's all. Thank you.